Welcome back. Let's take a look at two more terms. So we are in the algebra theory, and remember we have already looked at variable and constant. So we're moving on to the next term. And in this one, I'm going to start with inverse, because we left off on the last term with the concept of inverse, and I just want to take you a little bit further into that. So the new word is inverse. An inverse is a mathematical opposite. Okay, so I'll give you some examples. I'm not going to talk this to death. The examples hopefully will help you to see what I mean. Probably the easiest one to see is the addition-subtraction inverse. So add and subtract are inverses. And to give you an example of that, 3 plus 5 equals 8. So 8 minus 5 equals 3. So you see that what I am building up with addition, I can break down with subtraction. Those are mathematical opposites. They're mathematical inverses. So add and subtract are opposites. Multiply and divide are opposites. Okay. And an example of that would be 3 times 5 is 15. So 15 divided by 5 equals 3. Mathematical opposites, those are inverse operations. Okay, another one is fraction and reciprocal. And you maybe have never heard the word reciprocal, so I'll show you what that means. I'm going to zoom in just a little bit. There we go. So let's consider the fraction 3/4. Its reciprocal is 4/3. So I just turned the fraction upside down. I reversed it. Okay, another one is a square and square root. Those are inverse operations. And I'll show you an example. Let's take 3 times 3 is 9. So the square root of 9 is 3. And then similarly, we have cube and cube root. So let's take a look at that example. If you have 5 to the 3rd power, or 5 times 5 times 5, that is 125. So the cube root of 125 is 5. So those are also inverses. You will need to know about inverses to do algebra. It's a huge part of algebra. So we will see many, many more examples with these. Not so much the last two, but the first 3 for sure. Okay, the next one that I want to look at is the word term. And this is a common English word. You hear it in all kinds of contexts, social studies, science, lots of things. But in algebra, a term can be a constant. Remember, that's a number by itself. A variable, that's a letter. Or the product, that's multiplying, of a constant and a variable. So let me give you an example here. I'm going to give you an expression to think about. So let's say that we have 3x plus y plus z plus 4. Okay, this is called an expression, and we'll get to that in just a minute. I know that's one of your vocabulary words, and we'll talk about it in just a second. But let's take a look at the pieces that we can already identify. This plus 4 is a number by itself. That's positive 4. So this is called a constant. Okay. Plus z, that is a variable. It's a letter. Plus y, positive y, that's a variable. And then this 3 times x is a term that has multiplication. We're saying 3 times x. So this is called a multiplication term. And let me not do it this way. Let's do it this way. It has a coefficient, and I'll define that just a second down below. And remember, this is a variable. So we have a term with multiplying in there. So here is, let me draw it this way. Here is one term. Here is another term. Here is another term. And out here on the ends, you guessed it, this expression has 4 terms. Each of those pieces of the puzzle is one term. Let me go ahead and give you the coefficient definition while we're looking at that example. Coefficient is a number being multiplied by a variable. And you can see that very clearly in that orange term. A number being multiplied by a variable. So the coefficient is the 3 in that orange term. The variable is the x. And the 3x is one term. Okay? So this expression that we have up here, all of this together, we would say is an expression, and that definition's coming next, with 4 terms. Orange, green, pink, and blue, 4 terms in this expression. I'm going to pause this video. I'll see you soon.